Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about shell sort in Java. Shell sort is an optimization of insertion sort that improves efficiency by comparing and sorting elements that are far apart before focusing on adjacent elements. So in this video, I'll just code it and give you guys like a quick explanation, line by line, step by step. Let's get started with the actual shell sort method, right? So public static void shell sort. So we're declaring it with public static void, which means that it doesn't return anything as indicated by the void statement. Also, any element in here can be used throughout the whole class, as indicated by public static. It also takes one parameter, int array, which is the array that we're going to sort. So let's start. So first, let's talk about this first for loop, right? The gap sequence. So the first for loop controls the gap size, right? And okay, yeah, wait. I'll just say something. Shell sort starts by dividing the array into smaller subarrays based on a gap value. Shell sort it sorts the array using a concept of gap sorting, and it sorts the subarrays created by the gap value using an approach similar to insertion sort, right? So let's talk about the gap sequence. The first for loop controls the gap size. So this part over here. We initialize gap as half the length of the array. At each step/iteration, the gap is reduced by half until it becomes 1. The sequence determines how far apart the elements being compared are. Starting with a larger gap allows the algorithm to quickly reduce disorder in this array, right? So I'll just finish coding everything else. Right, so this is our shell sort method, completely coded. Now I'll explain some stuff, right? So let's talk about the second for loop, since I already covered the first one, sorting with the gap. So for each gap value, the second loop starts at the index gap and iterates throughout the array. This loop focuses on one subarray at a time, and it considers elements that are gap indices apart. These subarrays are sorted independently before the gap is reduced. Next, let's talk about this while loop. So if you've seen the video about insertion sort, this one might look familiar. Because shell sort is an optimization of insertion sort, they share similar characteristics, such as this while loop. So inside the second for loop, we use a while loop to sort the current subarray. So here's what happens. The current element, array of I, is temporarily stored in temp, right? So it's over here. We compared temp with elements that are gap indices apart, in the sorted portion of the array. If a larger element is found, it's shifted one position to the right. This process continues until temp can be placed in its correct position. By sorting these subarrays, we significantly reduce the amount of disorder in this array, right? So now let's talk about disassignment. Array of j equals temp. So once we find the correct position for temp, we insert it at array of j. As our gap decreases, the algorithm refines the sorting. The algorithm refines the sorting until finally the gap becomes a sorted array. The array is sorted completely using a final pass of insertion sort. Now let's see shell sort in action, right? So this is pretty similar to the other sorting algorithms. We can define an array. Let's just put some numbers in here. Oh, my bad. Alright, so we have some numbers here. So now, pretty simple. We just call shell sort of a array. It's kind of a tongue twister. Alright, so now let's do our printing process of the array using this for loop. Pretty standard across most modern sorting algorithms. And we print using IntelliJ's built-in shortcut for system.out.println sout. We print array of k. Not k, sorry, I. Alright, so now if we run this, we get our array fully sorted using shell sort. This works with any integer array, as you can clearly see. So we can visualize the process of shell sort, right? So we start with a large gap in the array, and we divide the array using this gap into subarrays. We sort each subarray using insertion sort, which is essentially what this while loop does. Then we reduce the gap and repeat the process, and we refine the sorting as the gap decreases. When the gap is 1, we perform a final pass of insertion sort to complete the sorting of the array. So let's summarize shell sort, right? To summarize, shell sort is an efficient improvement over insertion sort. By starting with larger gaps, it reduces the number of movements required in later passes. Shell sort has a time complexity that depends on the gap sequence, but it's generally faster than simple like time complexity of O of n squared algorithms such as bubble sort or insertion sort. So this is the time complexity for shell sort. Yep. So thank you guys for watching this Super 7 programming tutorial, and make sure to be updated for more future programming tutorial releases by Super 7.